Imagine finding water in places where we thought it was impossible. NASA's recent discovery of water in the sunlit craters of the moon has done just that. For years, scientists believed that lunar water could only exist in the permanently shadowed regions at the poles, where temperatures are freezing. But now, water has been detected in sunlit areas, challenging our previous understanding. This finding is crucial because water is essential for future lunar missions. It can be used for drinking, making oxygen, and even as rocket fuel. Knowing that water exists in more accessible sunlit areas could make sustaining human presence on the moon much easier. In this video, we'll explore how NASA made this surprising discovery, what it means for upcoming space missions, and how it could change our plans for exploring the moon and beyond. We'll also discuss the innovative technology used to detect this water, and the exciting possibilities it opens up for the future of space exploration. Stay tuned to learn about the moon's hidden resources and how they could shape humanity's journey into space. The moon, once thought to be a dry, barren wasteland, has been slowly revealing its secrets over the years. In 2009, NASA's Lunar Crater Observation and Sensing Satellite, LCROSS, found evidence of water ice in permanently shadowed craters near the moon's south pole. These craters never see sunlight, making them some of the coldest places in our solar system, perfect for trapping water ice. But the discovery of water ice was just the beginning. Over the years, further missions like Chandrayaan-1, a spacecraft launched by the Indian Space Research Organization, confirmed the presence of hydroxyl, a molecule related to water, in the lunar soil. Still, scientists believe this water was limited to the moon's cold, shadowed regions. After all, how could water survive in sunlit areas where temperatures can soar above 120 degrees Celsius? Enter NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA. This unique telescope, mounted on a modified Boeing 747, allowed researchers to detect water molecules in areas bathed in sunlight. This discovery shattered previous assumptions, proving that water isn't confined to dark craters but can exist even in seemingly inhospitable regions of the moon. But how did NASA confirm this? And what does this mean for lunar exploration? Let's break it down. The discovery of water in sunlit regions of the moon didn't happen overnight. NASA used the SOFIA telescope to analyze specific wavelengths of light reflecting off the lunar surface. Water molecules absorb infrared light at a unique wavelength of 6 micrometers, making it possible to identify their presence even from hundreds of kilometers away. In 2020, SOFIA observed the Clavius crater, one of the largest craters visible from Earth, located in the moon's southern hemisphere. The data revealed a significant signature of water molecules in this sunlit region. This wasn't just hydroxyl, which had been detected before, it was actual H2O. What's fascinating is how this water can survive. The moon lacks a thick atmosphere to protect it from the sun's intense heat, solar wind, or micrometeoroid impacts. Scientists believe that microscopic glass beads, formed by past lunar volcanic activity, might be shielding the water molecules. These beads act as tiny containers, protecting the water from evaporation or destruction. Another theory suggests that solar wind, a stream of charged particles from the sun, could be creating water on the lunar surface by interacting with oxygen in the moon's regolith, the layer of loose, dusty material covering its surface. This discovery was more than a scientific milestone, it was a game changer. But how much water are we talking about? NASA estimates there could be up to 100 parts per million in some areas. While that might not sound like much, it's equivalent to a 12-ounce bottle of water in a cubic meter of soil. Multiply that across the moon's surface, and the potential is enormous. You might wonder, why is finding water on the moon such a big deal? After all, Earth is teeming with water, but in space exploration, water is the ultimate resource. First and foremost, water is essential for life. If we want to establish permanent bases on the moon, we'll need a reliable source of water for drinking, cooking, and hygiene. Transporting water from Earth is prohibitively expensive. Every kilogram of cargo costs thousands of dollars to launch into space. But the benefits of lunar water don't stop there. Water can be broken down into hydrogen and oxygen, the two main components of rocket fuel. This means the moon could serve as a refueling station for missions heading deeper into the solar system, like Mars or even the moons of Jupiter and Saturn. This discovery also opens the door to sustainable exploration. Instead of relying on resources brought from Earth, future astronauts could live off the land, using the moon's natural resources to survive. This concept, known as in situ resource utilization, ISRU, is a cornerstone of NASA's Artemis program, which aims to return humans to the moon by the mid-2020s. And it's not just NASA that's excited. Space agencies around the world, including those in China, Europe, and India, are eyeing the moon as the next frontier. Private companies like SpaceX and Blue Origin are also developing technologies to make lunar exploration a reality. The discovery of water in sunlit craters could accelerate these efforts, making the dream of a moon base more achievable than ever. But what challenges do we face in utilizing this water? And how could this discovery impact the future of space travel? While the discovery of water in sunlit craters is groundbreaking, extracting and using it won't be easy. The water is likely distributed in tiny amounts across vast areas, making collection a significant challenge. One proposed solution is to use robotic systems equipped with advanced sensors to detect and harvest water-rich regolith. These robots could heat the soil to release water vapor, which could then be captured and condensed into liquid form. However, developing such systems will require significant technological advancements and investments. Another challenge is the harsh lunar environment. The moon experiences extreme temperature fluctuations, intense radiation, and micrometeoroid impacts. Any equipment used to extract water must be durable enough to withstand these conditions over long periods. There's also the question of sustainability. Extracting water faster than it can be replenished could deplete this precious resource, jeopardizing long-term lunar exploration. Scientists will need to carefully study the moon's water cycle, if it has one, to ensure responsible usage. Despite these challenges, the potential benefits outweigh the risks. Establishing a water extraction infrastructure on the moon could pave the way for future Mars missions and beyond. Imagine astronauts launching from a lunar base, fully fueled and ready to explore the red planet. This discovery brings that vision closer to reality. NASA's discovery of water in sunlit craters isn't just about the moon, it's about the future of humanity in space. This finding strengthens the case for the moon as a stepping stone for deeper space exploration. With water readily available on the moon, we could establish self-sustaining bases that serve as hubs for scientific research and space travel. These bases could support everything from growing food in greenhouses to testing new technologies for living on Mars. Moreover, the ability to produce rocket fuel on the moon could significantly reduce the cost and complexity of interplanetary missions. Instead of launching fully fueled rockets from Earth, we could send lighter spacecraft to the moon, refuel there, and continue their journey. This discovery also highlights the importance of international collaboration. The moon is a shared resource, and its exploration will require cooperation between nations and private companies. By working together, we can overcome technical and logistical challenges to unlock the moon's full potential. NASA's shocking discovery of water in the sunlit craters of the moon has transformed our understanding of our closest celestial neighbor. What was once thought to be a dry, lifeless world now appears to be a treasure trove of resources that could enable humanity's expansion into the cosmos. This finding isn't just a scientific breakthrough, it's a glimpse into the future. A future where astronauts extract water from the moon to drink, grow food, and fuel their journeys to Mars and beyond. A future where the moon becomes a bustling hub of activity, from research outposts to refueling stations. But this future won't happen overnight. It will take innovation, collaboration, and determination to turn this discovery into reality. Yet, if history has taught us anything, it's that humanity thrives on challenges. So, the next time you look up at the moon, remember, it's not just a beacon of light in the night sky. It's a world filled with possibilities waiting for us to explore. The journey has only just begun.